Hey everyone, this is a review of Ryobi's 18 volt OnePlus 150 watt inverter. So this lets you take any of their 18 volt batteries and turns it into a wall outlet essentially and a USB power source for low power electronic devices. So we're going to push this thing to its limits and see how much it can actually handle and what happens if you overload it. And then I'm going to give you the resources to calculate how long it will last with whatever load that you want and if it can power the device that you're looking to power with it. So here's the tool with a 4 amp hour battery. It's got a really easy to use user interface, just an on-off button. It glows green when you have power available in this outlet, and as well as the USB outlets, you just got to turn it on for these to work as well. It's got a flashlight up top, so this thing is great for power outages. You can just grab this and find your way to a more powerful flashlight because it's really just enough to see around in the dark, not really bright enough to do anything by. On the side here, you've got a nice grip that's built into it, and I like this because you'd have to, if you had a handle in it, it would be a lot more bulky, and this is really just about as compact as you can get on top of one of these 18 volt batteries. On the back, you've also got a lanyard spot where you can hang this from if you want to attach a lanyard to it. Now you notice this says it's a 150 watt, 120 volt AC, and then floating neutral. That means this is going to push current through both legs here, not just one. So both of these are technically hot. And what it's doing is it's gaining up the 18 volts to 85 volts, and then it's just switching polarity between these two, so you get 175 or 170 volts peak to peak as it switches between those. Charging USB devices on this is really simple. You just plug in the USB device and turn it on, and then you get power to here. It's a 2.4 amp shared between these two outlets. So if you plug two devices into this, you may have a problem with the charging rate slowing down. But it does do fairly quick charging with 2.4 amp output. Right now, this phone has 38% to go, and it says it'll take it 49 minutes. If you overload this past its rated 150 watts, this top button will just glow red, and then it will reset and try to power the outlet again. So if you have something plugged in that's trying to draw that current, it will just keep restarting over and over again. So what are the actual limitations of this tool? Because it's rated at 1.25 amps, and really it should cut off at 1.25 amps. But you have some tools, like this Dremel, that are rated at 1.6 amps, but it's a motor, so it's not always going to pull that amount of current. So I did a runtime test, or a test on this, and this Dremel is actually very usable on this, even though it's rated higher in amperage draw, and that's because if you really bog it down, it will draw 1.6 amps. But if you're not bogging it down, in using it normally, it's not going to draw that much current, and it will be below the cutoff threshold for this tool. So for motors and things like that, you may actually be able to get away with a little bit higher than the 1.25 amp rating. Otherwise, just look at the data plate on your tool or electronic device and see how many amps it draws, and if it's below 1.25, you should be good. I did try to run a 3 amp sander and a 5 amp Multimax off of this, and as you can see, they could start up and start going, but then on that startup load, they'd end up tripping the breaker on this, and it would reset the whole thing, and it would just be in an endless cycle of trying to start it, tripping its overload, and then trying to start it again once it had stopped drawing that current. All right, let's talk efficiency. So you have a watt-hour rating on the bottom of your battery. You can look at it. For a 3 amp hour battery, which is what I did my runtime test with, it is 54 watt hours, and that's just your amp hour rating times your 18 volt battery voltage. So I did a runtime test with a 43 watt light bulb and plugged that thing in, and it runs that just fine. It got 51 minutes, and if you do the calculations, it should have gotten about 75 minutes using that 3 amp hour battery. So that means you're only about 68% efficient in converting your energy from your battery to the actual AC power, at least for a resistive load like a light bulb. So to calculate how long whatever you want to run off of this battery and how long it will last, you can take the amperage rating on it, or if it's a light bulb, something like that, you can just take the wattage. But if you have to convert from amp draw, current draw, to wattage, you multiply, in this case it's 1.6 amps for this Dremel tool, times 120 volts, that gets you your wattage. Then you divide your battery watt hours by that, and you just get hours. So you got to multiply by your efficiency after that, and then if you want minutes, you can multiply by 60. So that works for anything you want to run on this. Just do those calculations and you can get an estimate of how long your tool or light or electronic device will last based on that calculation. One limitation of this inverter is that it is a modified sine wave inverter, not a pure sine wave inverter. So if you hook an oscilloscope up to your wall socket and look at it, you get a perfect pure sine wave that's nice and smooth, and that's what your electronic devices are designed to operate with, is that smooth sine wave. So nothing's designed for a modified sine wave, which is what this outputs, and it's essentially a square wave with a dwell at 0 volts. So making this a pure sine wave will require a lot more steps. It will require filtering with capacitors and inductors, and it gets more expensive. So this is a nice, cheap, and quick way to get a sine wave or an approximate sine wave out of it. But if you look at this waveform here, I hooked an oscilloscope up to the inverter. You can see it's essentially a square wave. So they have a step at 0, and that helps it act a little bit more like a sine wave, but it's not much more than a square wave here. So what that means is when you plug it into electronics, there could be a little bit of a voltage overshoot. If you zoom in on this waveform, you see there's a little peak right here at each transition point. And if you had a higher frequency oscilloscope, that peak might actually extend higher. So you're having higher voltages than the 170 volts peak to peak you should be getting, because if you take the RMS of that, you get 120 volts, which is what your regular wall power is rated for. And you also get a hum. If you hook this up to something with a motor, you're going to hear a hum, you're going to get more heat loss, it's going to be less efficient. And just as a quick example, I've got this box fan running on AC power right now, and there's not really any noise other than the fans moving air. So I'll go ahead and plug it into this and you'll hear the hum. So I think it's moving slightly less air right now, and you can definitely hear a distinct hum from that motor taking the square wave. And if you do have sensitive electronics, there is a possibility it could damage them. So if you have something you want to run off of this that's not just a resistive load or a motor, I would definitely call up the manufacturer or check their specifications for that product and see if it can handle a modified sine wave. So overall, I think this is a great little inverter and definitely something you want to add to your arsenal if you're on the Ryobi One Plus platform. I think the price point on this thing is excellent. I bought mine at $80 bare tool when it first came out. Ryobi has since lowered it to $59 bare tool. So I think it's a great deal for what you're getting for this, and it's a definite recommendation on my part. So let me know if you have any questions in the comment section below, and once again, don't forget to subscribe.